Good morning, everybody, and welcome to the video. My name is Saumil Shah. I'll be your host, mentor, instructor for this video tutorial series. This video is all about building data lakes. Yes, that's right, building data lakes using Apache Hudi. If you don't know what Apache Hudi is, you are in the right video. I'll make sure that you know almost all part about Apache Hudi. There are amazing hands-on lab which will make your concepts much more clearer on Apache Hudi, and why industry is adopting Apache Hudi so much, and why is it so trending, right? So all of that would be there in this video. So basically, first we'll take a high-level overview on what is Apache Hudi and try to understand a little bit, right, about the features. And once we do understand, I promise we straight jump into demo and labs. We'll essentially build our Hudi data lake. We'll try to insert, update, delete, then query the data using, of course, Spark, SQL, and we'll also try to run ad hoc queries using Athena, and all about Hudi. And then maybe at the end we might do a lab on streaming ingestion using Apache Hudi, right? So all of that is in this video. I'll be your instructor. So let's get started with the video. So now let's see basically what is Apache Hudi and why is it so trending, right? So let's get started. I'll basically hop on the official website and try to give you a little background here. Before that, Apache Hudi was made open source by Vinod. He's ex-Uber, and he's the brain behind the Apache Hudi. So yeah, I just wanted to say great job. Thank you for making that as an open source. He's also the CEO of OneHouse, right? So let's get started with Apache Hudi, right? So Hudi brings transaction, record level updates, deletes, and changes to the stream to the data lakes. So what is the problem with data lakes, right? The main problem with the data lakes are essentially, say you want to delete a record for some compliance reason. Now again, you have thousands and thousands of objects. Now to locate that one object, and then essentially in that file you'll have thousands of record. You have to scan, eliminate that, and then rewrite that particular file. It's challenging and it's tricky. And then essentially for data lineage and data quality, you have to maintain the metadata, which makes it even more challenging. Now you might want to roll back, you might want to run incremental queries. All of these are some of the challenges with the data lake. Apache Hudi is an open source. It helps you to again solve all these problems. There is no cost. It's free, open source. Okay, so let's take a look at the architecture a little bit. On a high level, again, you have your data lakes on S3, again, or any other cloud platforms that you have. I'll preferably use S3 for the labs as well. And then here you have your data sources, right? Your data sources can be through databases, event streams, or microservices, right? For example, you might want to bring certain data into the lakes for maybe analytical purposes, right? Because ideally, your database will have 1 year of operational data, and then all your history can be found on the data lakes, right? So basically, Postgres, MySQL, Cassandra, event streams are basically Kafka, real-time streams, right? So all these data will essentially be dumped into S3. Now, Hudi is basically the way I like to teach people in a very simple way is think of this as a top-level wrapper around the S3. So basically, Hudi will maintain all the metadata, all that stuff is been taken care by Hudi. And then here you have your popular query engines such as, for example, Athena, which I love it, as I said. You can also query via Spark and other stuff as well, right? You can build your pipelines using Hive, Flink, Apache Spark. These are the ways in which you can build your pipelines, right? Now let's take a look at the features of Hudi. And first of all, understanding features is so much important. Again, Apache Hudi supports upserts, delete with fast pluggable indexing, transactional rollback, concurrency control. Actually, Apache Hudi has one of the best concurrency control, is how I would say, based on reading articles, right? Automatic file sizing, data clustering, compaction, cleaning. What does that mean? Basically, we all know that smaller files are essentially good in terms of write latency, but they're not good in terms of reading data. Because when you read data using Athena or any other sources, smaller files are a bit hard because it consumes more memory, and versus a larger file will give you about 70 times faster performance and speed improvements while querying the Hudi data set, right? So larger files are better, right? And probably we want to use a Parquet file, right? So file format, file sizing, all that is taken care by Hudi. Okay, that's what it's trying to say. Again, built-in metadata tracking, again, all that is taken care, backward compatible schema evolution and enforcement, streaming ingestion built with CDC sources and tool, SQL read write from Spark, Presto, Trino, Hive, and more. Again, very, very popular. And I also wanted to show you, again, there's an article by Airbyte, which again shows sort of the popularity of, again, Apache Hudi. So here again, if I can quickly show you, the green line is the one with the Apache Hudi, and again, just see the growth of Apache Hudi since 2017. It's amazing. A lot of companies have been adopting, very popular, open source, right? Again, if I had to show you more detail, here is an article by One House which shows you the power of Apache Hudi, right? So for example, copy on write, merge on read. Datalake doesn't support merge on read. So basically Apache Hudi does support that, right? Again, bulk inserts, efficient bulk inserts. Apache Hudi is much better for performing bulk insert, right? So what I'm trying to show you is the green checkbox will check on almost all the boxes, and here you can see this is why you might want to adopt Hudi, right? So again, you can come here and go and read all these details, but again, I am a big fan of Apache Hudi, and again, most of all the boxes are checked by Apache Hudi. And again, based on the articles that I've been reading, a lot of companies have been adopting Apache Hudi, all right? So hopefully this gave you a little bit high level idea about Apache Hudi, right? And now let's try to basically do some labs and understand the Hudi concepts in a detail, right? Again, assuming you don't know anything, right? You don't know anything of building data lakes. We're going to create our first S3 bucket. We're going to create our Hudi table, insert, update, delete, compaction, clustering, all that stuff we're going to do in this lab. And if we still have time, we will also do streaming ingestion with Apache Hudi. So yeah, a lot of interesting stuff. So let's get started. But guys, before starting the lab, I think some theory is important on Apache Hudi. Again, the concept of COW and MOR is important. A lot of people don't understand that, and hence I will spend about 5 to 10 minutes reading this concept, because I believe this is really important for you guys to understand COW, MOR before we jump into the labs. So before we jump into the labs, let's understand the concept a little bit, okay? So what I will do is here, I'll share my screen, of course, in a second. And again, this is taken by on an article from by Siva Bala Narayan. Again, an amazing article where I was able to understand these concepts pretty well. So first, what I'm gonna do is I will try to take a pen here. Is it work? Okay. So there are two types of table in Apache Hudis, that is COW and MOR. Again, this is important for you to understand. Again, I'll try my best to do the theory in a little in an easy, fun way as much as possible. But you need to know this concept, guys. This is important, okay? So COW and MOR. COW stands for copy on write. MOR stands for merge on read, okay? Now, again, before we go into this, data lake stuff, let's understand the basic. So what is data file? Data file is basically your Parquet file which holds data. Again, as simple as that. I'm just gonna go very easy language. Okay. What is a delta log files? Basically, what happens is whenever you insert, update, delete, basically the Hudi will maintain all that in an Avro file or an external log file, right? So that is called as a that file is called as a delta log file, basically in simple language. What is a file group? So as I said, you have your data file, the blue one where your data lives, right? And then basically any insert, update happen. Basically, it is inside a log file, right? And together a log file and the data file, they together constitute a file group, okay? As easy as that, okay? What is a file version? So what happens is, anytime you insert, update, delete, Hudi will essentially create a new file. So which means the updated record, right? So this is again a second version of that file. So again, that is called file version. Again, very simple language, right? Now, basically what we need to understand is copy on write, right? This is something that I wanted to make sure that you guys understand in a very easy way. Excuse me. Oops. So assume you have these the blue boxes are your data files, right? Your Parquet files, which holds the data, right? Now what happens, guys, is anytime there's an insert, update, delete happening, what happens is basically it will essentially create a new file, right? So what Hudi is gonna do is basically it's gonna store all the again, very easy language I'm using, all the insert, update, deletes, all the changes rather in the log files, right? And then what it's gonna do, it's gonna do a merge basically from the old file and the new data items, and it's gonna create a new data file, right, called as version v2. So again, in COW, if I had to show you quickly. So in COW, what happens is basically anytime, let's say in this file, right? Let's say you added, you updated, let's say name is equal to, I don't know, like let's say name is equal to ABC, right? So that essentially goes in a log file, right? And then basically Hudi will say, okay, let me compare this and this, and then it's gonna create a new data file. Now, when the reader, or when you try to query the data, now you will read essentially from this file, right? Not from the older files, right? So that is the concept of basically COW, or also called as copy on write, which means when you are writing data, it's gonna create the new data files, right, basically. So hopefully that made sense. Again, I will cover more now, again in a very easy way. I don't want to go too much into theory part. So in more, what happens is the same concept, guys. You insert, update, delete, you have your delta log file, right? Now the merging of these two, that is the the updated, let's say you updated a record, basically all that goes in a log file, right? Now the merging essentially happens based on the conditions you provide. So now you will say, oh, you know what, hey, I want to essentially merge after, let's say, 2 commits or 4 commits, right? So that process again, that stuff is done after a certain condition. So that is basically a MOR, right? Again, depending upon your use cases, you may decide to choose either a COW model or a MOR model, right? That is, COW stands for copy on write, MOR stands for merge on a read. Okay. Again, I wouldn't go too much theory, but again, just a difference. Write latency, as we discussed earlier, COW has a higher write latency when compared to MOR due to a synchronous merge happening during the write. Again, pretty self-explanatory. This means when you basically insert data into, or when you update data, right, it will essentially put into the log file, delta log file also called as, and then it's gonna merge, right? So has a little higher latency when you are writing data. Again, makes sense, right? Now, read latency. Since we have to do a real-time merge in MOR, right? In MOR, basically you do a real-time merge, right? MOR tends to have a higher read latency, right? When compared to COW. But again, if you configure all the compaction strategies pretty well, it should work pretty well. Okay, that's all we are trying to say. So from this slide, all you need to remember in a nutshell is COW and MOR. Okay, there are 2 models, COW and MOR. Okay, what is COW? Copy on write. What is MOR? Merge on read, right? So in COW, what happens basically is basically so when you write data, the write latency might be a little more, but it's not that crazy. Okay, in MOR, the compaction basically happens after, basically when you're reading data, right? Basically, in a nutshell, let's put it this way: after a certain condition is met, that does happen. Okay, let's put it that way. Again, for beginners, I don't want to make it too crazy. So hopefully that is it for the theory that you need to know. Now it's time for labs, which means we are going to jump into a practical demo, which means you have to do this labs with me. Do keep in mind there is going to be like about a $4 to $5 cost. So glue, because we're going to use glue, and glue is not under a free tier, so make sure it's okay with you, right? So let's get started with the hands-on lab. That is, let's get started now creating our Apache Hudi tables. All right, let's go. Let's do it, man. It's time for labs. Okay, so what I'll do, I'll close all these tabs here. Again, the code and all is all there. So let's try to focus more on learning part. Okay. So the first thing that we want to do is basically we want to go to an S3, right? And then what we want to do is basically we want to create a bucket. I actually already have a bucket. So if you see glue learn beginner, I'll delete everything from this bucket. Okay, I'm deleting every single thing. It's an empty bucket. So we'll start fresh here. Everything deleted. Okay, so make sure you have a bucket. My bucket name is called glue learn begin. If you don't have a bucket and if you want to practice or learn, click on this orange button, give it a unique name, and then all the way on the bottom click on the orange button that says create bucket. So this should help you to create an S3 bucket, right? And so now we will come to the bucket. So the first step is create an S3 bucket. Pause the video and resume once you're done. Okay, I hope you have the bucket now, right? Now the next step what we want to do is we want to head over to AWS Glue. So this is the Glue console, right, over here. Now over here you have to go to the job section. Over here, as you can see my cursor, right, click here. This should open up on a new tab. I am on the Oregon region. Again, it doesn't matter wherever you are. So yeah, now what you want to do is click on the Spark script editor. Okay, over here. Actually, I also want to say the settings, so I'm gonna click here. Okay, so now click on the Spark script editor and then click on the orange button that says create. This is what you would see. Now come to the job details and name this Learn Hudi crash course. Put it anything, just give it a good name, right? Okay, then in the IAM role, if you don't have an IAM role, you please create an IAM role. I essentially made a role with admin privileges. It's not a good idea, but it works fine for this, right? So I'm gonna make IAM role. Over here on the drop down section where it says the Glue version, I'll use the version 4.0, which now natively supports Apache Hudi. Over here in the workers, I'll use 3 workers, okay? Number of retries, I'll use 0. I don't want to retry, and then I need to do certain settings in the additional settings. So come down where you see job parameters, right here, click on this button that says add new parameters. Now here we have to add 3 of them, so I'll make 3 boxes here, and then what I want to do is I'm gonna copy these because I already have it here in my other lab. So we're gonna provide a hyphen additional Python modules. We're gonna use a Python module called faker again to create or generate some fake data. So I'm gonna copy this. Again, this will be there in the description, the commands, and I think I do have if I'm not mistaken, yeah, I think I do have a guide here as well, which I'll leave it in the description. So if you come here again, it shows choose Glue 4.0, add these items, and here it's given here as well. So okay, so don't worry. Okay, so now I'm gonna copy the conf, right? So I'm gonna say conf, and then from this PDF I'll copy this one. Okay, great. And now I'm gonna say data lake format, and then we are gonna use Apache Hudi here. Okay, so here we're gonna say Hudi, and that's all, right? That's all you need to do. And here in the tags, just add a tag. It allows you to monitor the cost. I'm just gonna say product learn whatever, because I'm learning or I'm teaching, right? And that's pretty much it. Now come to the script, click on the button that says save, and your job should be saved. Now again, this is all the settings that we need to do, and now here we are going to write some Spark code. Okay, so now I'll head over to my IntelliJ IDE. I'll comment out everything, and we'll go step by step, so don't worry, I'm not going to hurry on stuff. Okay, so okay, over here again, simple, right? Nothing crazy, right? We have couple of built-in imports, and here I'm essentially importing Spark session, Spark, and Glue context, basically just the default imports. Here I'm importing a library called faker. This library is used to generate some fake data. Now here we have a database name, and here we will call HudiDB. Let's name this HudiDB over here. So change this to HudiDB. Okay. Table name, you can name any table that you like. Let's call this as Hudi table. Okay, and over here, this section over here, put your S3 bucket and make sure your base path starts with S3A : / the bucket name. This is where you're gonna put your bucket name, right? And then here I'm just creating a final S3 path, right? So basically it's gonna be this and concatenated with the table name, right? That's basically what all you need to do. Remember, all you need to do is change the database name to Hudi DB, table name to Hudi table, and make sure you put your appropriate S3 bucket. That's all you need to do. Again, I wrote a simple class, a static class. So this generates some fake data. So as you can see, again, it generates a name, a fake name, and some fake items, right? Now I'm gonna collapse this one. I have a function that creates a Spark instance, right? Here I'm creating a Spark instance. This returns a Spark instance. So here you can see on line 64, I'm calling Spark session, right? So I'm calling this function and I'm gonna have the instance here. And then I'm also creating a glue context here on line number 66. And this is where the interesting part starts. So all the configuration that you wanna do, basically we have to specify in a dictionary. So here I'm saying in my data, again, I have a data, right? Every data will have a primary key or a unique identifier here, right? So I am saying that if you observe carefully here. So here I'm saying on line number 70, I'm defining a parameter called Hudi table name. And this is the table name, right? So we gave the table name as Hudi table, remember that? And the database name is Hudi DB, right? So hopefully you guys are with me so far. Over here, we are using merge on read. We are not using a COW, we are using a MOR model here. So merge on read. Over here, Hudi write record key field. So this is a required, it's a mandatory. So here you gotta give a unique identifier or a primary key in your data. So in my data, I know that employee ID is gonna be unique. So I'm saying to the Hudi, when you create that, employee ID is a unique identifier, okay? Again, I'm giving a table name here, and here I'm specifying upsert, which means basically when you find something similar, okay, if you find it, update it. If you don't find, insert. So I'm saying an upsert here, okay? So that's that, right? Again, these are just some default settings, I would say. Again, I'm using, these are pretty standard. I don't think I need to go over these, right? So I'm not gonna cover these settings. Again, it's pretty standard one, right? So yeah, I mean, so now the thing that starts here is now we want to create our first Apache Hudi, we want to create our Hudi table, right? I'm gonna comment out this code and I'll explain you what this does. Data generator dot get data. So what this does is basically this will get the data in form of list of tuples. So for example, like this, I'm just gonna show you quickly, okay? So again, PCD. Okay, so basically this will give the data in this format, okay? And then here I'm defining the columns, right? So I have an employee ID, employer name, department, state, salary, age, bonus, and TS. Again, just some parameters I'm just specifying. Again, we'll see later on how to convert your existing data from S3 into Hudi, right? So again, that's that, right? So again, very straightforward, right? df is equal to spark.create data frame. So here I'm creating a Spark data frame. Just like pandas create data frame on line 95, I'm essentially creating a Spark data frame. And here I'm saying df.write.format, and here I'm specifying the format as Hudi, right? Options, so I'm giving all these options that we specified. These are important options, right? Make sure that you have that, right? And that's that. Mode as overwrite, because I'm gonna overwrite that, and then here I'm providing the S3 path. All the other code is commented out, so we don't need to worry. So right now we are generating 5 records and we're gonna insert into the Hudi data. So now what I want you to do is copy this, okay? And then come here, remove everything, paste your code here, click on save, and then head over to the glue for beginners. Again, there is no data here, observe this carefully, okay? Now this is our glue script, learn Hudi crash course, and I will start the glue job. So my glue job has been started. Now it's in the running state. Now I'll show you what happens on the side. Meanwhile, what you want to do is open up AWS Glue and click on database. Here I do not have a database called Hudi DB. We will see a database being created shortly. So be patient here, okay? Now my glue job is running and will resume once the job is complete. All right, so the job is now succeeded, as you can see. And now what I'll do is I'll head over to the glue, head over to the database. And if you refresh, here you will see something called Hudi DB. If you click here, you will see two tables, Hudi table RO and Hudi table RT. Now you'll be like, what? I just said one table. Why did you make two tables, right? Let me explain. So if I go to this blog post, which does explain the concepts, what I was talking about. So RO and RT stands, so RO stands for read optimized view. So let's read, okay? Provides the latest committed dataset from a COW table and the latest compacted dataset from a MOR table. Again, this is a read optimized view, okay? RT stands for a real-time view, which means provides the latest committed data from a MOR table by merging the columnar and the row-based files inline. So again, you have two tables, right? So RT will be the real-time view where you will see all the latest commits, right? RO would be a read optimized view, which means these are more better for query purposes, right? So if you read here, when you query the read optimized view, the query returns all compacted data but does not include the latest delta commits. Querying this data provides a good read performance but omits the freshest data. You can query the real-time view. Again, you can query the RT. Hudi merges the compacted data with the delta commits on read. The freshest data is available to query, but the compactional overhead of merging makes the query less performant. The ability to query either compacted data or the real time allows you to choose between performance and flexibility when you query. So again, depending upon your application and use cases, you can either query the RO table or the RT table. Again, if you now come here and if I try to query the RO stands for read optimized view, right? So again, you should see your data here, right? So if you come here, so here you can see employee 0, I think I just have to order that. So let me just do an order by employee ID. You can also do a cow model. We'll see that shortly. Don't worry about that. Order by. Let me just run this again. Just want to show you quickly. Remember, now we are querying an RO table. It's a read optimized table. Okay, so here you can see 0, 1, 2, 3, 4. These are the 4 employees that we have, right? And I'll do the same thing now. I'll read the RT table, right? That is the real time, which will have all the latest comments, right? So now I can come here and say, hey, you know what? I want to read this one. And let me just run the query again. And the Athena query is running and I should see the result shortly. So now let's scroll here and here you can see the same data we have, but this is the RT, that is the real-time view. So far that's great. We have a Hudi, right, table. We were able to query that in Athena, right? Let's see what the S3 looks like, right? So quickly going to the S3, I'm gonna refresh. Here you can see there's a folder called Hudi table. And here if you observe, there's a metadata file .hudi folder where Hudi, maintains all the metadata and commits, right? And then here you have your data file, or also called as a Parquet file, right? Basically, hopefully that made sense. So now, since you have a Hudi table, now let's try to update certain things, or let's try to append into the data lake, okay? So let me share my screen, okay? Now going back to the stuff. Now what I'm gonna do is I will be commenting out these code over here. Here you can see I've commented out, and I'm gonna uncomment the append operation. Now again, we are appending into the data lake. Again, same thing. I have a record 6 and 7. Again, employee 6 and 7 is not there on the data lake, right? Or on the Hudi table, right? 0 to 4. So this would be probably an append operation, right? So again, now we are saying your mode as append, and then we're going to do an update as well in the next part. Okay, so now I'm going to copy this code. Okay, then I'll go to my glue job. Again, I'm going to go to my Spark job. I'm going to edit this, click on save, and then over here I'm going to click on run. So this is going to run my job. Now my job is in the running state. Right now, again, I'm expecting the record to be appended, right? The 6 and 7, these are not there on the data lake, right? So let's see what happens. I'm going to resume once this is complete. Okay, I am back and the job has been succeeded. So as you can see here, right? Now again, what we did is essentially we basically performed an append operation on our data lake, right? So again, if you remember, if I refresh here, I should see some files here. I can see 2 Parquet files have been added. Now remember, we are doing a MOR model, right? Basically, MOR has 2 tables, right? RO and RT. RO stands for read optimize and RT stands for the real-time view. Real-time view means it will have all the latest commits. RO might not have the latest commits because it has to do the compaction. Basically, it has to merge the file, right? Based on the condition that we have provided. So let's see. Don't worry. Okay. So back on my console here. Now heading over to the Athena. Again, same thing. I'm gonna run the query. So let me, I don't need this one, close that one. Okay, so here I'm doing a query on RO table. RO stands for read optimize. So let's see, do we see the record 6 and 7 or not, right? So again, we had 4 records, right? And now if I come here, I see my record number 6 and record number 7. As you can see, they are right in here. Great, that's exactly what I was expecting. Now let's go to the RT, that is the real-time view as well. And let's make sure if we do see the data here as well. So I'm gonna query my RT, and here also you can see, I can see both of them here, as you can see, right? That makes sense. So now basically what we did is essentially we did an append operation, right? Now let's try to update any particular data here, right? So I'm gonna try to update some records. So I'm gonna comment out this code over here which says append, and I'll basically head over here and essentially do an update. So I'm gonna update where the record number or the employee ID is 3. So I'm gonna change this to, this is an update, okay? So now what I'm gonna do, again, same thing for the update as well. I'm creating a Spark data frame, and then essentially I'm using the mode as append, and now I'm assuming since the record is already there, since in the configuration I defined as an absurd, this should essentially find and update it, right? So let me copy all of that, and now again I'll go to my glue job. I'm gonna save, and then I'm gonna run the job. And here you can see now the job is in the running set. I'll resume once the job is done. So the job is complete. Again, as you can see, it's in the succeeded state, and let's see what happens. So again, remember what we did? We have updated the record now. So if I go here in my S3, let me refresh and see what it looks like. And here, as you can see, it looks like there are like some delta log files here, right? And the metadata files, again, we don't have to worry about that. Now let's try to directly go to Athena and see if we see an update. This was my older one, right? I'm gonna run the query first on an RO table and see if I can see that update. RO stands for read optimize. Again, as I said, and RT stands for the real time. RT will have all the latest commits. RO might not have the latest commits, right? So now coming here, and if you observe carefully, look, this is an RO table. We do not see an update. And why? Because again, remember, RO might not have all your latest commit. Again, depending upon the condition, it will perform the merge, and then only you will see in the RO table. RT will have all your latest commits, okay? So coming back, again, this is my RO table, and now I'm querying my RT table, okay? I'm gonna run my query here, and let's see if we see an update, okay? And again, Apache Hudi gives you all these out of the box, guys. I mean, look, it does all this stuff for you, okay? So again, look at that, look at that. So here you can see this is an update, and here this is my RT table. So what you learn from this is in a MOR model, you will have 2 tables, RO and RT. RO stands for read optimized view, RT stands for real-time view. RT will always have your latest commits, and RO might not have it's an optimized, read optimized view, right? It again, depending upon the condition that you put, like, for example, after 4 commits, do a combine. It will do all that after that, okay? So that condition is important, okay? So as you can see over here, we have a create. We are essentially inserting into the Hudi. We are appending, update, and then delete. So basically all the operations have been taken care here, right? So now what I'll do is basically I'm gonna start the job. I deleted all the database from Hudi here. Head over to the script section, right? Click on save. So that's being saved, and now I'll click on run. and you can see it's in the running state. This will take about 7 to 8 minutes, so I'll resume the video once this is complete, and then we'll basically try to query this using Athena. Now remember that this is a COW model, which means copy on write. Here we have said copy on write, so just an FYI. So I'll resume once it is done. Okay. So now you can see the job is succeeded and took about 7 minutes, right? And if we go to the Glue database, refresh, here I should be able to see my Hudi DB and a Hudi table over here, okay? So I'm gonna go to the Athena and click on launch query editor. I'm simply gonna refresh that, click on Hudi DB, close all these tabs here, and then I'll basically try to query my data now. Again, we did a complete CRUD operation here. So let's see if we can see the data. Here you can see, actually, you know what, hold on one sec. I wanna just do an order by so we can see things. Order by employee ID ascending. Gonna click on run. And basically, if you observe here, 0, 1, 2, 3, again, fourth one is deleted, third one is updated. Here you can see this is an update on the data lake. 6 and 7 was an append. So here you can see that, right? So what we essentially did is basically complete CRUD operation, insert, update, delete. We did that. Now, what I want to show you is quickly, if I have a, one sec, let me try. Okay, so now I just want to show you one last thing. That is basically you can also again. So remember how we did the delete? We essentially wrote Spark SQL, right? So basically now you can also do that, right? So you can say select star. You can use your SQL skills here, right? If you don't like to use Python, you can use also SQL to interact with Hudi, right? You can select based on a certain criteria. You can update, delete, do whatever you want basically on the data lake, right? We also saw on how to consume that data on the data lake, right? So essentially, we were able to run ad hoc queries using Athena. That's doable. Another thing that I want to mention is, Amazon Athena has announced Notebook Explorer. So now you can have Spark notebooks here. Basically now you can also query your data using sort of a Jupyter-like notebook, right? So if you don't want to query using Athena and you want to query via Spark, you can do that since, Amazon has recently announced that, right? So hopefully that made sense, right? So again, I hope these videos and demos are useful for you because these are meant for beginners, where I went from the basics, right? Like, what is Hudi? Okay, how do you create a Hudi table? Okay, then how do you insert? How do you update? How do you delete, right? What are the different types of table, right? So basically we covered almost all the basic part that you need to know to get started with Apache Hudi. And if you find any bugs or if you have any issues, do make sure to open up an issue on the GitHub section on their official repository. They are usually pretty fast in responding to your issue as well. Okay. So the one thing that I'm now interested is, I have all these files, right? So basically when I now query, so if you observe, right, when I query the data using Athena, this is the latest file, that is 567.parquet. So if you come here, 567.parquet, this is where my latest data, that's my latest data file, right? So what I want to do is basically, as you know, right, this is your Hudi data file, right? Any updates, insert goes into the log file, and then in the COW, it essentially merges that, and then basically generates a new data file called version v2, right? And every time, update, insert happens, it will generate new data files, right? What I want to do now is basically I want to prune or delete all these older files, right? And for that, I'm gonna use a settings or a flag here. So here you can see over line 155, Hudi cleaner policy, keep latest file versions. Again, you could do that by also doing, by keeping the latest commit. You can do by doing keep latest file versions. You can also say keep latest by hours. So maybe, might want to do on last 24 hours or 36 hours or so on. Or you can also run it independently, the compaction. They have like snippets here. So this is something that I want to try. So I'm going to copy this and I will head over to my glue job, paste this one here and click on save. And then I'm going to run my glue job. So now my job should be in the running state. Did I run that? Let me make sure I saved. Okay, that is saved. And now I will run the job, and now it is in the running state. So now I will resume once the job is complete, and I'm assuming, my assumption here is the older files shall be pruned. That's the sort of the goal here. Okay, so let's wait and let's resume back once this is complete. Okay. So observe that the job is now complete, says succeeded. And if we go to Athena, and if I refresh, here you can see now there are only 3 files. Versus before, if you observe, there were about 6 files. So it did do the compaction, right? Yeah, so that actually works, right? So all you need to do is just say, you can specify whether you want to keep the latest file versions, or you can do that as mentioned in the documentation. You can do that by keep latest commits. So if you do keep latest commits, it's gonna be probably a MOR table, I'm assuming, and keep latest by hours as well. So yeah, you could run these commands, and that would essentially prune your older files that are not needed, right? So that's that. I guess I'm gonna conclude the video right here, and this essentially have showed you everything about Apache Hudi, and it should help you to get started with Apache Hudi pretty fast. So insert, update, delete, we did a compaction, and then if you want to read further, you can go to the official documentation, read more. With that being said, if you have any further questions, let me know. I will try my best to answer them. If I don't know, I'll try to get back to you by asking someone, right? And that's pretty much it. Thank you so much for watching the video, and I hope this video will benefit you in creating data lakes using Apache Hudi. With that being said, keep smiling, keep programming, and I will be seeing you guys in the upcoming next video.